All right, today we're going to be looking at section 2.3. This is additional displays of quantitative data. And I want to give you a couple of study tips as we begin to do the overview for this lesson. One, I would recommend you go to each assignment and then look at each of the questions. So you can come here and you can kind of thumb through and see what all you're going to be asked to answer in each section. This will give you an idea of what to focus on as you go through the lesson. As I go through them, I'm just going through an overview. So it's not completely comprehensive of everything that's in the section, but it gives you like a general idea of what you need to focus on. So one good thing is just to kind of go through and look at all the questions. You can kind of see everything that they're asking you. And then once you go through all of them, you can kind of see everything that you'll be asked to answer. Then you go to the textbook. And so I'm going to start here in the textbook. I'm just going to give you an overview of the information here in 2.3. And then we'll start answering those questions. So one of the things that we did see is stem and leaf plot. So you're going to be asked to draw a stem and leaf plot. They define them here. I'm going to just show you the example. So you've collected some data. These are the steps they're kind of going through. You've collected some data, and we want to present it in a really condensed way so we can gather the information really quickly. And so what they do is, as you look at all these numbers, all of them are 1 or 2 digit numbers, and then they are followed by 1 decimal point. So you come up with the stems. Those are going to be like the whole numbers, and it could be different in each data set, but they come up with the stems, and then the leaves are the decimal points that follow. So they start with 7, which is the smallest, and they go all the way to 19 using this data set up here. And then each of the numbers that follow the decimal point would be the number on the other side, which we call the leaves. You have to have some kind of legend that tells people what to do with this, otherwise you wouldn't know. Sometimes this could be 1,901 maybe, or it might be something else. It might be 191. So they need to tell you what the leaves are. In this case, it's saying that whatever comes behind the vertical bar is a number after the decimal. So this is that information. They have 2 different ones. One, they just listed it as it was given, so it's not in any specific order. And then over here, they listed the stem and leaf chart in order from smallest to largest. So you can see it's out of order here: 6, 5, 3, 5, 7. Then over here is 3, 5, 5, 6, 7, going in order from smallest to largest, or ascending order. So this is what we call a stem and leaf chart. We will be asked to make some of those. So here's another one. Tells you the leaf are 0.1. So here we just have 2 digit numbers, and then they make a stem and leaf chart where the first place is the tens digit, and then the place after the bar is going to be the ones place. And so again, they do 2 different ones. This one is called a split stem and leaf chart. So when there's so many data points on one row, what they do is they split it up into 2 sections. One is 0 through 4. So these numbers are 0 through 4, and then the second half is going to be 5 through 9. So it kind of just makes it not so many numbers on one row. So again, 0 through 4, and then 5 through 9. So this is what they call a split stem and leaf. We'll be asked to find the midpoint. The midpoint are going to be used to do frequency polygons. In order to find the midpoint, we're going to find the sum of 2 consecutive lower class limits and divide it by 2. So here we have a table, some data, some lower class limits, upper class limits. They add 50 in the next lower limit, divide by 2, and that gives you the midpoint. So that's what we're going to use as the x-axis label for the frequency polygon. So here you just see all the midpoints. Once you find one midpoint, one thing you can do is just add the class width all the way down. So add 25 and you get the rest of them. So that's one neat thing about finding midpoint and using that class width. So here is a frequency polygon that used the midpoints, and then the height of each of the bar represents the frequency of that class. We have a cumulative frequency distribution where the bar goes in ascending order from smallest to largest, and each height of the next class is everything that is less than or equal to that frequency. So that's what this description is saying. So here's some data. Then we have a it looks like ogive, but it's pronounced ogive graph. This goes in ascending order using that cumulative frequency idea. So your first bar is at its original height, and then the next bar is this height plus what happens here. And so each value is going to be adding and either just going up. So it puts them in ascending order. That's what it says. Represents the cumulative frequency, so you add as you go. Upper limits are the cumulative frequencies of that class and all the previous class added. So we will be asked to do some ogive graphs, and then you have a time series. Time series just kind of puts the time in order. So you got a sequence of events and then their heights, and so then you have a time series graph where the x-axis is labeled by the year or some time period, and then the y-axis is the height or the frequency. One other thing that's very helpful is technology. So they allow you, or they show you some steps to produce these frequency polygons or ogive graphs or time series plots using 84 calculator. You can do it in Minitab. You can do it in Excel, StatCrunch, and several different programs. So I would definitely recommend that you take some time, enter some of this data, and see if you can produce some of the tables that were given here for examples. So with that, those are going to be the displays of data. We're going to go ahead and jump over to MyMathLab and start working.